accepting our invitation. We look forward to your enlightening speech. We have another celebrity in space science as a guest of honor, Dr. Esam Hegi, Chief Scientist at Qatar Environment and Energy Research Institute, KIRI, and Research Director, Earth Science Program at Qatar. Dr. Hegi, your gracious presence in today's and previous events means a lot for us. Thank you, and we warmly welcome you, sir. To enlighten us on the contribution of Vikram Sarabhai, we feel honored to have Sri Jayant Sahasrabuddhe. I humbly welcome Sri Jayant Sahasrabuddhe, National Organizing Secretary of Vigyan Bharati, as a guest of honor. Thank you, Jayant, for being with us. I warmly welcome Sri Babu Rajanji, ICC President. We are indebted to ICC for their consistent support. On behalf of Science India from Qatar, I welcome and recognize the cordial presence of embassy officials, dignitaries from Qatar Foundation, Dr. Greg, Director of Qatar Academy of Science and Technology, distinguished guests who joined us from India, Dr. Lalit Sharma from Department of Science and Technology, India, Dr. Paresh Joshi from Homi Bhabha Center of Science Education, Mumbai, school principals, presidents of apex bodies, SIF GCC Organizing Secretary Sri Abkaji, SIF Qatar founder member and advisor Sri Shashidharanji, presidents of all associated organizations, executive committee member of SIF chapters in Gulf region, Dr. Satish Krishnanji, SIF president from UAE. Once again, I welcome you all. We sincerely acknowledge and thank Science Department of Ministry of Education Qatar for the opportunity given to SIF students to be a part of Qatar national team for International Junior Science Olympiad in 2019 and International Chemistry Olympiad in 2021. SIF Vice President Dr. Jagdish Sharma was one of the trainers for Qatar Olympiad team this year. SIF Qatar is providing a bridging platform for the Indian scientists and researchers working in Qatar. SIF have promoted Vaibhav Summit, where many Indian scientists participated and contributed from Qatar. SIF have conducted deliberation on the science, technology, and innovation policy, and attendees gave their valuable inputs in framing the STIP to the Department of Science and Technology of Government of India. We recently announced Qatar Children's Science Congress, that is QCSC, and I request all present here to encourage students to participate in this innovative science program for aspiring child scientists. We invite students, teachers, and parents for the orientation program scheduled tomorrow at 4 p.m. and it will be conducted by Dr. Lalit Sharma, Chairman, National Academic Committee of National Children's Science Congress, Department of Science and Technology, India. Zoom meeting details are available on our website as well as on Facebook. So with the support of Embassy, ICC, all Indian schools, we could conduct 26 activities even during COVID lockdown period. And with this, I request SIF Secretary Mrs. Sujata Gokhale to play a short video on SIF activities. Thank you once again, and I welcome you all. Thank you.
Thank you, Deepak ji, and thank you, Sujata ji. Now I request ICC President Sri Babu Rajan ji to address on opening of session. Over to you, Sri Babu Rajan ji.
Thank you, sir. Respected Chief Guest, Srimati Angelina Pramalada, keynote speakers, dignitaries, and leaders, participants online and offline. What is the most beautiful feeling in our life? Respect and love. It is not only for living legend, it has to extend for all legends, even if they are not with us. Science India Forum, Qatar, making an event for remembering the great scientist of India, great son of India, late Padma Vibhushan, Sri Dr. Vikram Sarabhai. In Doha, I know all organizations are doing lot of activities, but Science India Forum doing something different. They're always thinking about environment. They're always thinking about humanities through science. And I know this organization coordinating scientists, Indian scientists from not only from Qatar, not only from India, from all world. Even today also one guest from America. I just heard you are giving good morning. So please continue the work on behalf of Indian Cultural Center. We always there for support to India Science India Forum. And I am very thankful to the organization for inviting me for such a great event with a great academician and educationist and scientist. Once again, thank you for all. Thanks. Jai Hind, Jai Qatar.
Thank you, Babu Ranjan ji, for such an encouraging words to us. May I now invite our chief guest, Srimati Angelina Premlata ji, for the inaugural address. Srimati Angelina Premlata ji is Counselor, Political and Commerce, Embassy of India. Over to you, ma'am.
Thank you. Distinguished speakers, Sri Sudhir Kumar, Dr. Essam Hegi, Sri Jayant Sazragurde, other dignitaries present here, President ICC, Mr. Babu Rajan, President of Science India Forum Qatar, Mr. Deepak Dahake, friends from Qatar, India, from the US. A very good evening to all of you. First of all, may I say it's such a privilege to be here among this audience. Notable person experts in your respective fields. Thank you, SIF, for having invited me today. May I place on record my congratulations and appreciation for the work that Science India Forum has been doing. Like Mr. Babu Rajan said, as we celebrate 75 years of India's independence on the 15th of August, to commemorate the father of India's space program, his birthday, 102nd birth anniversary today by organizing this event, is the best homage that we could pay to him for the great achievements that he's done, for having led the way for the Indian space program over the last from uh, from the establishment of ISRO in 1969, from having set up the first our launch station in Tumba, to having guided, I believe even he even contributed to the India's nuclear program. For someone of that stature, it is only right that we have an event today with eminent speakers like we have on our panel to commemorate the great life and the work that our scientists have done over the years. And this being the 75th year of our independence is a good time to to sit back and see the achievements that we've done over all these years, and to also reflect on how is it that we can take forward. So if I look at the space program of India, beginning with setting up, I believe there was a predecessor to ISRO as well. From then until now, one thing that strikes me, one thing that stands apart is that The whole space program has something that is based on international cooperation. Be it the first time we launched our Indian satellite Aryabhatta, which was from the erstwhile Soviet Union, to the achievements that ISRO has had over the past so many years, it's all been international cooperation. And I see that we have some first to our credit, be it the Mars Orbiter mission in 2013 and in 2014, where India was the first nation to succeed in its maiden attempt, or be it in 2017, where ISRO launched as a record 104 satellites, and out of which 101, I believe, were of other countries. So it is all based on international cooperation. And it is also with a sense of pride that I say that we are also collaborating with Qatar here, with Ishaisat, with their own satellite agency. And it is because of institutions like Science India Forum who making it possible to kindling that interest. Like I see that you're having a quiz contest, you're getting students involved. So it's the younger generation that's going to take our achievements forward. So congratulations on doing that. Now, it is also with a sense of pride that I say that I am from a country that has had a space scientist occupy the highest constitutional post in India. So that is the kind of respect, that's the kind of honor we give to our space scientists today. So if ISRO today, like Mr. Deepak said, if ISRO today is counted among the top 6 space agencies, it's the hard work that our scientists have done and continue to do, and the great achievements. And another thing is that our space program, the way it is meant to contribute to socio-economic development, to making, to contributing, say, to agriculture, to weather forecasting, to be satellite-based remote education. So that's been our focus. We take everybody along, and that is one speciality of India, I would say. So, and we have, like I mentioned, in our milestones, we have, to our credit, having launched close to 350 foreign satellites and from 34 countries. And we have a lot. We continue to have memoranda of understanding with many countries with whom we collaborate on our space program. And also another point of that to be noted is that we have an excellent training program for our scientists. We have institutions recognized by the UN that award, that conduct courses in ranging from satellite meteorology to remote sensing. So I think I would leave the rest for the experts to talk about, because I feel among the stellar presence we have today, I'm someone who has a very basic knowledge. So thank you for inviting me today. It's such a pleasure. I'm here representing my ambassador, who unfortunately could not be among all of us here. He has other commitments. But I'd like to assure that on behalf of the embassy, we'll continue to provide all possible support to Science India Forum and to the efforts that you will take. And thank you all. Thank you for this. And may I know Science India Forum is conducting more events over the next few days, and all the very best for all of that as well. Thank you so much. Thank you for the opportunity.
Thank you, ma'am. Thank you for your encouragement. Well, due to, as mentioned earlier, due to some urgency, His Excellency Dr. Deepak Mittal, the Ambassador of India to Qatar, could not attend. However, he has sent us a video message. Now, let us listen to the Ambassador's message. May I request Saleja ji to, Sujata ji to please play the video, please.
Namaskar. Good evening, Mr. Sudhir Kumar, our distinguished scientist and director from the Indian Space Research Organization, Dr. Hisham Hagi, the chief scientist of the KERI Qatar, Shri Jayant Sahasrabuddhe, National Organizing Secretary Vigyan Bharati, my colleague Ms. Angeline, a counselor in the embassy, Mr. Deepak Tahage, President of the Science India Forum, other distinguished panelists, those watching today this event. It's really a warm welcome to all, and it's my great pleasure to be able to join you through this message. First of all, today, this event being organized by Science India Forum to commemorate the birth anniversary and to remember the work of the great Indian scientist, Padma Vibhushan Dr. Vikram Sarabhai. It's really a unique event because it is coming on the eve of the Independence Day of India. In a few days, we will be celebrating the 75th Independence Day, celebrating 75 years of our independence. It is really remarkable that this event has been organized around this time when we will be able to recall the great contribution of Dr. Vikram Sarabhai to the development of modern India, especially in the space and the nuclear sciences. These last 75 years, I think, is in some of the a period when India has emerged as a leading nation worldwide, especially in the space sciences. We have a credit of launching more than 100 space missions, be it Mangalyaan or Chandrayaan. We also have a lot of other plans in terms of launching Aditya and Gaganyaan too in coming future. We have been launching satellites not only for India but also for the world. We have launched more than 300 satellites. We have a record of carrying 100 satellites in one go. This is the strength which our space missions have. We always recall our Mangalyaan, how our mission to Mars was one of the cheapest. As our Honorable Prime Minister once remarked, it was even cheaper than the movie Gravity of the Bollywood, at a 1/10 of the cost of what we achieved. This is the strength of Indian science. This is the strength of Indian space science. And today, when you are organizing this event, you are celebrating that Indian science, the Indian scientists, especially Dr. Vikram Sarabhai, who laid the foundations for such developments. From time when our space program started, I have vivid recollection of the photographs, the images of our rockets or the satellites carried on the back of a bicycle. And today, when we have modern equipments, we have launching pads, and we are giving services to everyone around the world. I'm happy to share that even with Qatar, we have initiated dialogue in the space sciences, and hopefully it will see some positive results in coming times. Science India Forum has been instrumental in organizing a lot of activities promoting science here in Qatar. We have been igniting interest in science in the school students, in the expatriate community in Indian side and also others, building bridges between Qatar and India, the community itself. I'm sure in coming times, when we talk about our government's initiative of connecting Vaishvik Vaigyanik Bharat, the BHAVAV, nicknamed as BHAVAV Summit last year, I'm sure a lot of scientists who are connected with it, the Indian scientific mind here in Qatar, would find space through such a BHAVAV initiative of the Science India Forum in coming days, when you organize more such activities. Science India Forum, I know, has plans to even do Children's Science Congress and do more such activities over the next coming year as part of our Azadi Amrit Mahotsav, celebrating 75 years of India's independence. I wish Science India Forum the very best, and I'm confident even today the celebrations of Dr. Vikram Sarabhai will bring out the strengths of India, celebrate our 75 years, and also give us ideas how we look at next 25 years, what are the objectives in the next 75 years, especially in the science, where we would like to be in next 25 years when we will be celebrating 100 years of our independence. With these words, I once again thank Science India Forum for giving me this opportunity to share these thoughts. I would have liked to be present physically, but due to my other commitments, I could not be there. But I'm very happy to share my thoughts and to be able to associate with this initiative of the Science India Forum, and to be also join this august gathering of a panel of speakers today. Once again, good wishes and best wishes on the Independence Day of India. Jai Hind.
Thank you, sir. Today, we have with us our guest of honor, Sri Jayant Sahasrabuddhe ji. Let me share the screen. Sri Jayant ji is an electronics engineer who dedicated his service in popularizing and promoting Indian scientific heritage. Since 2009, he is working for Vijnana Bharati as National Organizing Secretary. He was an organizing committee member of various international conferences, and to list a few, like World Ayurveda Congress, Global Indian Scientists and Technocrats GIS Summit, India International Science Festival IISF, Bharatiya Vigyan Sammelan BVS, etc. Conducted more than 100 lectures on the topic Vivekananda and Science in India as well as abroad. He is co-founder of Global Indian Scientists and Technocrats GIST Foundation, co-founder of Vigyan Prasar Bharati, co-founder of National Environment and Energy Development Mission Needs. May I now request our guest of honor, Sri Jayant ji, to talk on Dr. Vikram Sarabhai's contribution to space program. Over to you, sir.
Namaste. Honorable Chief Guest of this function, respected guests of honor who have joined us, distinguished speakers of this function, and all the participants who have gathered over here in this August function. It is a moment of joy and pride for all of us that we are all set to celebrate 7th year of independence of our country, which will begin on the 75th day of independence, that is coming 15th August. We all know that today we are remembering father of our Indian space program, Dr. Vikram. We also know that we are supposed to celebrate this 75th year of independence by remembering our freedom fighters who dedicated best of their life for the liberation of their country from the clutches of oppressive foreign rule. But we need to remember this, that they were not just freedom fighters, but they envisioned glorious India of the future. And we are all here to fulfill their dreams. So it is our duty and responsibility to understand their dreams, their vision, and how they could think about that through science and technology, we will be able to take our country to a greater height. We can develop country in such a manner that our country will become intellectual leader of the world. We all know that in our freedom struggle, our scientists did all kind of efforts to achieve swatantrata, that is independence. And they could think about this great fact that science can be a great tool to challenge the hegemony of foreign rulers. They could understand the importance of science and technology in this modern era. And they laid a foundation for the Swatantra Bharat, independent India. And we all know that today we are celebrating great advancements which we have in the field of science and technology. When we are remembering such freedom fighters who were scientists, today's hero to whom we are remembering today, that is Vikram Sarabhai, he was amongst them. And he did imbibe that nationalistic spirit as a scientist, and he could envision that India should be a part of great countries who have done great science and technology through space programs in this world. So he used to think that we should do all kind of progress in the field of science and technology. And he pushed everything, he did everything to push the space program in our country. He did establish that program, and he felt that our country should be second to none in this domain also. So it is a great moment of joy as well as pride to all of us that we are remembering him today on the eve of 75th year of independence. I need to appreciate all the efforts done by Science India to inspire our young minds so that they can imbibe the scientific spirit of our great scientific leaders, and they can make glorious future for this country. So I wish you all the best, those who have joined this program and those who will try to understand and imbibe the great spirit of Dr. Vikram Sarabhai. Namaste.
Thank you, Jayanji, for your interesting talk and profound message. It really encourages us, sir. Now, it gives me immense pleasure to introduce our today's keynote speaker, Sri Sudhir Kumarji. Mr. Sudhir Kumar is Director CVPO, ISRO headquarters, and is responsible for capacity building in the areas of research and academia interface, startup incubation, industrialization, indigenization, technology transfer, IRP, technical infrastructure, and outreach activities of ISRO. He did. I hope I'm able to share. He did his graduation in mechanical engineering, post-graduation in industrial engineering and space studies program at International Space University, Austria. On joining ISRO in 2000, he played key roles in developing enterprise software solution. He was the core team member for realizing Asia's largest solid rocket propellant plant at SDSC Sahar, Sriharikota. State-of-the-art mission control centers, assembly and integration facility for GSLV Mark III project, radars and critical equipment for launch complex. He was in charge of second vehicle assembly building project, largest rocket integration facilities at ISRO. May I now invite Sri Sudhir Kumarji to deliver keynote address on India's space mission and its facility. Over to you, Sri Sudhir Kumarji.
Thank you very much. Mrs. Angelina, Jain Saab, and Deepak ji, Abha, and other Qatar friends joining from Qatar. I'm wordless, I should say. The words you're talking about, the Indian space program and the scientists. I don't have any words to say. Probably I think we were thinking when we get exposed to the people, our actions will reflect in the general public. When I get to know beyond our limits, country limits, when somebody is talking about the Indian space program, I don't have words to say. Thanks a lot. Only one word I can say. I'll be indebted to you, and Indian space program will be with you always. Can you just enable me for sharing the screen? And in the meantime, I'll continue. The Vikram Sarabhai is the father of space nation. Many people talk about, Jainji talked about. And he was the person who started the space journey. He was a fascinate on the space journey. When he joined DAE along with Baba, Homi Baba, he was having some research on the, still it is not enabled, who's disabled attendee screen like that. And he took the space program up. Initially, the INCOSPAR is the committee where he could push through in the DAE as a part of DAE. And DAE, Homi Baba had given a lot of support through the then Governor Jawaharlal Nehru to start a INCOSPAR space program. So with that, the space program, in fact, started from DAE. That's what DAE, we call it as the parent organization, which took the seeds of Indian space program. He managed to use the program, the platform of DAE at the maximum to push the Indian space program. Ultimately, parallelly, he was doing the directorship at DAE and carrying out the space activities on a parallel platform. And his contribution is, as Ms. Angelina explained, the international space contribution or international cooperation started not with Apple, even the first rocket, Nike Apache. I'm still struggling to share my screen. Host disabled attendees.
Let me make you co-host, Sudhirji.
Okay. You try. I'll continue so that continuity will be there. And the first rocket was Nike Apache was given by USA. The computers were given by France. The helicopters were given by Russia. Such a kind of international, and the Tumba has become a platform for international cooperation. So the international cooperation started from the day one. So I just wanted to appreciate how actually the Indian space program started with such a legendary and a holistic legendary. Without paying tributes to him on this occasion, probably I think we should not start the Indian space program. I pay sincere tributes to the father of the Indian space program, Dr. Vikram Ambala Sarabhai. His blessings always be with us. So coming to the space program, Indian space program, I'll just cover it as early as possible. If I spill for a couple of minutes, please pardon me. And the more or less the space program covers three segments: ground segment, space segment, and space transportation. Ground segments are the users. Space segment is the different satellites that will impart the space applications, and the space transportation system is basically the launch vehicles and etc., which will carry the satellites from the ground to the space. I hope the slides are moving.
Yes, sir.
Yes, sir.
Thank you very much. Thank you very much. This Indian space program predominantly will have some kind of let us say, parts, what we call it as the space segment. As I said, Earth observation, communication, navigation, space planetary missions, which will be covered by different types of satellites. And space transportation is predominantly by the launch vehicles, whether it is spendable launch vehicles or reusable launch vehicles. And space applications, which is basically remote sensing applications, communication applications, navigation applications, which will be in point of view, the market point of view, it will occupy almost 60% of the total revenue that is generated out of the space business. But of course, capacity building, which is hidden part of it, is basically deals about the infrastructure that is required to carry out all these activities, the human resources, the technology part, the international cooperations, industry academia contribution, and of course, very important thing is outreach. Ultimately, we have to reach out to the missions to these different people. These are all the space applications, ISRO missions. There are remote sensing missions, planetary missions, deep space missions like Mangalyaan, interplanetary missions, which are proposed science missions, space science missions like AstroSat, which has brought international different academia on a common platform to have a research. Of course, I'll just touch upon each and every aspect so that the people who are listening will get to know most of the things what we have covered in the past and the future. We started our journey with the SLV3, where our Abdul Kalam Saab was the project director. We learned lessons for basic learning in the rocket sciences, then developed the ASLV with the 2 strap-ons. That has given a lot of lessons how to fight with the weathers and atmosphere. Then that led to a PSLV, which is a most robust vehicle, which can be deployed for multiple missions like both Earth observation, polar satellites, polar launches, navigation, that is, let us say, navigation launches or communication for putting the satellites into the geostationary transfer orbits, which will be transferred to the synchronous orbits. That was not enough because payload demand was more and PSLV can carry only a maximum of 1.9 tons. Then we had to acquire the technology of cryo. Again, still Russian friends helped us for initial stages. And with that technology, after nurturing, we have developed our own cryogenic technology with indigenous vehicle, which what we call it as Bahubali of ISRO, GSLV Mark III, which will carry 4-ton satellites to the G2 orbits. and where this particular vehicle I belong to, because I contributed for this vehicle. That's what I'm proud to say. This is a very important vehicle for us. And this vehicle is being operated to carry 6 tons. Of course, why? The one is fascination to gazing the stars, to get to know about the universe, multiverses. But ultimately, Vikram Sarabhai meant the space application should be reaching to the common man. What common man uses? The land use, land cover, where actually the urban cities are there, how to map the roads, how to map the rail routes. Let's say how many acres of filling is there, what is the water resources available during the rainy season, so that water catchments will be channeled to useful areas during the non-airy seasons, where the fish is available. Normally, the fishermen, when they go into the sea, they do not know where the full catchment would be there. The Ocean Sat will provide that facilities, and we give the to navigate to the fishermen so that they drive to the potential fishing zones. They can have a boat full of then environment disasters management. And ISRO happened to be the club in of the disasters warning and management system, which will predict the tsunamis, which will predict the cyclones, several such kind of catastrophes. In fact, in the couple of in the last decade, we proud to say that several thousands of lives were saved, which otherwise could have been catastrophic. So these are all the remote sensing. When a satellite is up in the sky with the different sensors, with the different cameras, we project, we take the help of these applications, we map it, we give the feedback to the users, like farmers, like government, like industries. Of course, intercommunication satellites is another area where the satellites, we do depend on satellites, but children have to know when you are talking about the mobile, through the mobile phone, when you are using your ATM, when you are talking in the to your friend, when you are in the remote area, where for telemedicine, for tele-education, these communication satellites are inevitable, using for your amusement. Another dimension to the space applications is navigation. Popularly, we call it as, because GPS has come first, GPS belongs to the USA. The navigation system, which will point out the location accuracy and location identity of different more terrestrial on the sea-bound as well as aeroplanes. And this will give the location, not only location, our navigation system is a peculiar one. It sends the messages also. And it sets the timing across the nation. I get to know because I used to sign some of the technology transfers. One of the POSOCO, they have said that in the national grid, because India is a very vast country, between Kanyakumari and Kashmir, if you can synchronize the timing, that will lead to crores of savings on the power. That is the advantage the NAVIC system has got. Of course, deep space mission, somebody talked about the Mangalyaan. The technology that is involved in the Mangalyaan was never envisaged by the ISRO. The first time when it had operated the Mangalyaan mission, we were also surprised, because when this particular satellite goes behind the sun and several months it was not appearing, we do not know whether the satellite is there or gone into the deep space. The moment first appearance, it has come back into the visible connectivity. In the first instance itself, we could catch the satellite and we started tracking that one. So after several months and after 60 crore kilometers away, an object being tracked at the first instance is an amazing thing. Our technology scientists, is a textbook kind of thing. Okay, that kind of predictions we could make, that kind of technology we made it. That is the pride of India. Of course, moon missions are very popular and fascinating missions. Even though we were not the first in the moon missions, but we were first to. We were also very successful technologists to reach the moon in first attempt itself. And it is to our pride that our sensors, our mission has identified the hydroxyl molecules on the lunar surface, which shows that yes, some water is available on the moon surface. That the Chandrayaan-2 mission, very ambitious mission, which we intended to reach a unreached surface so far by any national space agency, was quite successful to reach orbital parameters, reaching to the moon surface, breaking the moon atmosphere. But last moment, because one unexpected or anything has happened, ultimately the mission was not 100% successful. But still, the orbiter which is moving around the moon is continuously taking the images and making our life so fascinating with the different mapping of the moon and several technological data. It's not enough. While expanding the launch vehicles, we were also concentrating based on the demand of the world. The world is going more towards the small satellites. We thought that we should also develop a small launch vehicle for affordable launches by many private industries, so that small satellite market also can be captured and we can facilitate the Indian industry. So this is almost development is through, except for a minor hitch in the last moment. Again, this is a versatile launch vehicle with fully solid propellant, which will promise the reliable launches, 100% reliable launches of these small satellites. Gaganyaan mission, yes, it is a very ambitious target. Our Honorable Prime Minister of India has put it across to the ISRO. Because of COVID, some delays were there because it's inevitable, because the entire world is suffering because of this pandemic. Except for many of the technologies, including re-entry experiments, padabot tests, parachute qualification, the materials, ELSS, astronaut training have been completed. We are just waiting for a couple of months to have first unmanned mission, followed by second unmanned mission, and the third mission could be with astronauts. And here, international cooperation was applauded. We should mention in case of human-related launch vehicles, orbital module, these ISRO expertise were used. But in case of crew training, life support systems, and flight suits, the international cooperation was sought, and the international space agencies were quite helpful or quite friendly with us to share their technology. As I was telling, this particular GSLV Bahubali of ISRO is now getting operated to take 7.5 tons to the G2 orbit. The ones the technology is proven, probably or why definitely the ISRO will be more self-sufficient even to launch 6-ton class of satellites into the geotransfer orbits. The reusable technology, which is another very important technology, which has been demonstrated with a small prototype, and the mechanisms have been understood, because in this technology, when it is returned back, what kind of dynamics that are involved, including the re-entry, winged body, that is very important. The technology demonstrator has been successfully demonstrated, but it's only just a scaling up. Probably, I think we are waiting for some more payload capability increase. As soon as that is over, we can launch after the Gaganyaan as a part of extension program. This is another technology I just wanted to mention for the scientific community. When we take the satellites into the orbit, exhaust gases only make the vehicle to move before injecting the satellite. But why we should carry air? Because we do carry oxygen as well as fuel. When oxygen is available in the air atmosphere, so to that extent, if the capacity, the loading of the propellant is reduced, we can increase the payload. So this air-breathing engine is a very critical technology. Very few nations have demonstrated this technology. We had a test run, and it is the test run in the first run itself, it was quite successful. Again, it lands into the scaling of the prototype to have a full-fledged flight. We have very scientific and very impressive missions ahead, which have been approved, which are in the pipeline. One is the Aditya L1 mission, which will dedicated solar mission to study the very dynamics of solar atmosphere. NISAR is a joint development between NASA and ISRO for studying the Earth biomass increase. Space docking experiment, X-ray polarimeter. This is a purely scientific machine to study the dynamics of astronomical sources in the extreme conditions. Of course, if you don't talk about the launch pad, I don't think ISRO, the space activity would be complete. We used to have several launch pads which are not operational right now, because SLV and ASLV, the old launch pads, now they are archives. And we have two operational launch pads, first launch pad and second launch pad, what you could see in the view graph. Both the launch pads, one is inside. The first launch pad, which was commissioned maybe to in the late 80s, will carry most of the PSLV launches. The functioning of this launch pad is on IOP concept, what we call it as integrate on pad. That means the rocket will be assembled on a static pedestal, what you see like a table. And the assembly building, which will be used for assembly of the rocket, will be moving back and forth. The assembly building weight is around 4,500 tons and the height is 70 meters. Can you imagine such kind of gigantic building is moving up and down? You can just a small video how the building will be moving. You can just visualize. These are all the wheels, 1.1 meter wheels, which will carry 125 ton axle load. Normally, the train what we carry, it only carries 12 ton, the highest loading, but it will take 125 ton per axle load. You just imagine the quantum and the giganticness, the extreme engineering that is involved in the launch pads. The second launch pad is basically ITL concept: integrate, transfer, and launch. The rocket is assembled inside the concrete building and will be transferred to the launch pad by using a mobile launch pedestal. The second launch pad has got two assembly buildings, so that the launch pad will be optimized. So parallel integration can take place in both the buildings. So it has got platforms automatically. They will be folded up and down for making the integration. Ultimately, it will be unfolded to make the way for the launch vehicle to move out of the building. And this is around 1 kilometer, the distance between the assembly building as well as the launch pad. And when it is moving on the moving launch pedestal, a bogie which will weigh around 4,500 tons maximum, it will lift the entire mobile launch pedestal along with the rocket and takes the launch vehicle from assembly building to launch pad. And when it is positioned in front of the launch pad, the final day of operations like fuel filling and electrical checks will be carried out at the launch pad. That will take 7 to 8 hours. After that, it will be ready for launch. Of course, third launch pad is also in the way, because when we are going for higher lift launch vehicles, the second launch pad also may not be sufficient for us to cater to the heavy lift launch vehicles. The third launch pad is also in the conceptual stage. But as a part of this one, we have already realized one second vehicle assembly building, which is around 100 meters tall, 70 meters width, and 50 meters deep, having 450 ton EOT crane on the top. Whatever the imagination that you see, you cannot imagine such kind of voluminous infrastructure in the launch pad. I was heading this building before coming to the ISRO headquarters. The production facilities, because solid motors need to be produced within the short distance, because these 100 tons solid segments cannot be traveled in the public roads, because it requires very safety operations. That is why the solid propellant plant was conceived or was established near to the launch pad within the launch, which is Sriharikota Island. This is the Asia's largest propellant plant we have at the Sriharikota, which will produce solid motor segments, S200 segments, and transport to the launch pad for final integration. These are the several phases of launch segment production. And each, you can see the person who is standing there, what is the height of the launch vehicle. These are all automatic operations, because very high level of safety is involved. Any kind of small mistake that will cause huge catastrophe. Once the launch vehicle subsystems are prepared, they undergo very severe and stringent testing for vibration, for acoustics, and ground testing. Ground testing is very important. Each and every solid motor and liquid motor has to be tested on the ground. And after 1 or 2 tests, when all the parameters are satisfied, then only we will induct them into the program. These are all some of these liquid test facilities at Mahendragiri near to Kanyakumari, and some of the solid test facilities are in Shar. These are all some of the view graphs. This is the L110 test going on during 2007 or 8. Of course, this other part of the thing is satellite, which is very important system for the space domain. Most of the systems will be generated in the industry. When it comes to the URSC satellite center, where all the components are assembled and tested, they have to undergo several vigorous testing, like radiation testing, antenna testing, then EMI, EMC testing, inertia testing, thermal testing, etc. When all the testings are over or completed satisfactorily, finally the satellite will be put inside the thermovac facility for sealing. Once the satellite is sealed, the sealed satellite will be sent to launch pad for integration. Of course, the launch, how it does, when the launch vehicle, all the communication satellites will be eastward launches, all the polar satellite vehicles will be southward launches. We have several stations during the launch across in the trajectory of the launch vehicle for tracking and for any other purpose. We have several PSR tracking radars, both in SHAR, VSSC Trivandrum, Mauritius, Brunei, Bayak, Lucknow, for tracking the launch vehicle all through the trajectory path till it injects the satellite into the orbit. And this particular tracking radar, I must mention, is a technological marvel. Only very few countries, I think 2 to 3 countries only have got this multi-object tracking radar. When the debris is in the space, the debris monitoring is this responsibility of the National Space Agency. So with that view, indigenously, we have developed this particular multi-object tracking radar, which is a technological marvel. This is the antenna inside the radar. So ultimately, when the launch is ready on the final day of counting operations, all the scientists day and night, I think when we go to the launch pad, probably we work even 24 to 36 hours continuously without even break. We used to get lunch and tiffin and breakfast to our desks. That is the way ISRO scientists will work. I think that is what the people are also mentioning about, because we cannot leave, that the job demands that we cannot leave. These are all the different computers and different control systems. People will have to monitor the activities 24/7 before the launch. And weather is another important parameter to be observed on the day of launch. The rain, no problem will be there, because during rainy season we have done several launches and it will not disturb the launch. But thunders will disturb the launch, because the discharges, heavy discharges. That is for that reason we provide lightning protection towers around the launch pad, launch vehicle, so that if any heavy discharge is there, that will be grounded. And we observed several times these discharges and vehicle was safe. These are all some of the view graphs. I just wanted to show how the assembly will be done. It is not that one entire rocket will be transported to the launch pad. Several subsystems will be transported. They will be assembled one after the other in the vertical stands. And after the stage is completed, it will be transferred to the mobile launch pedestal for integration. Once the integration, these are all the upper stages launch vehicle. The heat shield itself is 8.6 meters. You just see people are standing on the platforms. When final stage integration is completed, it will be rolled down to the launch pad for the final launch. After it reaches the launch pad, the final day of filling operations, checkout operations will be carried out. Huge amount of fuel is required. 110 tons of liquid propellant, maybe 25 tons of liquid hydrogen and LOX will have to be filled into the propellant tanks. These propellants will be stored at a very far off distance, because these are all very safety hazardous operations. 24/7 surveillance, highest order of security surveillance will be provided on these facilities. After that, launch will take place. And after the launch, several tracking systems will be there. When the satellite is injected, the controls will be taken over by MCF Asan as well as ISTRAC ground systems, and they will, using this for deep space missions, we have very specific radars like 32 diameter parabolic radar, 18-meter radar. All these radar systems will be used for satellite monitoring and controlling. I think when the successful mission is there, people take joy and celebrate. And ultimately, we are the people who uses the space technology. Thanks a lot for, I think if I, couple of minutes, if I exceed, I pardon. I beg pardon. Thank you. Thank you.
Thank you very much, sir. It's really enlightening us and making us feel proud with the capabilities of our space capabilities, and all. Really very interesting. And we would really love to have more on this, sir. It's really wonderful. Thank you very much once again.
Thank you. Thank you.
Now, it is my pleasure to invite Dr. Essam Hegi to present on space programs in Arab regions. Dr. Essam Hegi, Chief Scientist at Qatar Foundation and Research Director of its newly established Earth Science Program. Research Scientist at Viterbi School of Engineering in the University of Southern California and affiliate of the Radar Science and Engineering Section, NASA Jet Propulsion Laboratory. He obtained both MSc and PhD with distinguished honors from Sorbonne University, Paris. Dr. Hegi's research interests in space and planetary geophysics aim to understand subsurface water and ice occurrence and distributions in Earth's arid regions, Mars, the Moon, icy satellites, and near-Earth objects using radar techniques. Dr. Hegi's works in a wide range of space exploration projects, including with the Mars Express Orbiter, the Chandrayaan-1, the Lunar Reconnaissance Orbiter, the Dawn mission, the Rosetta mission, and ESA ExoMars rover. He is also a contributing scientist in planetary and terrestrial radar imaging and sounding experiments, including the RMIE radar on the JUICE mission to Jupiter and Envision radar for Venus. Now, Dr. Essam Hegi to present on space programs in Arab regions. Over to you, Dr. Hegi.
Can you unmute, sir?
Okay, yes, I am unmuted now. Well, good morning, everyone. Do you hear me?
Yes, we can hear you, sir.
Okay, well, it's very, very difficult to do a good presentation of the Dr. Kumar presentation. I am impressed. I can just watch it for hours. And I hope if Dr. Kumar is listening, still online, that we can organize a side discussion, and maybe we can organize a visit for Qatar Foundation to ISRO to talk about future collaboration in our Earth Science program. So, and I may charge our friend in the Science India Forum of Qatar to be the liaison and to help organize this, because this is just amazing. So if I can share my slides, maybe, yes, so I'm able to share. If you see my slides, on a much, much less impressive notes, actually, I'm going to talk about the significance of exploring the planets and Earth evolution, especially for us in developed nations. So many of the people would say why we should care about going to the moon, why we should study Mars, deserts. We have so many problems, from food security to irrigation to water, and then we should focus on these. And it's a fantasy to go to these planets. Well, that's not true. And in fact, that's what I would try to show in my presentation. So I'm, as a scientist, my research focuses on understanding water on a global scale, on planets, on icy moons of Jupiter's, on the moon. And basically, why this is important, because every part of these planets we go and explore tell us something about the phase our own planet went through. So for instance, Mars would represent the future of our planet. It will become ultimately a desert. Venus is maybe the early phase of the moon. It's maybe the phase of the Earth. The icy moons of Jupiter, they represent the Earth during the Ice Age. So going to explore each of these planetary bodies is not a luxury. It helps understand how our own planet evolved. And that's the research I'm working on. So I work in 3 places. The first one is Qatar Foundation, where I'm in charge of the Earth Science program in Qatar. So it's a new in space program in its infancy. We just are 2 years old, and the program basically aim at understanding the regional changes in desert areas and how deserts around the Earth respond to climatic and anthropogenic changes. So right now we started collaboration with NASA, with the University of Southern California. We hope with Azadi and the French, the University of Paris space program, we hope to establish, we are now in the discussing of this collaboration. And actually, after all what I've seen, and we've been looking for this for a long time, to establish also collaboration with ISRO. So we have a single space project at right now, and the project is a sounding radar that is a low Earth orbiter, sun-synchronous sounding radar that is being formulated with NASA under Space Act agreement between NASA and Qatar Foundation. And it's a venture discovery light class mission, which is mean that it's a mission ranging in budget between $200 million to $300 million. And it aims to send this sounding radar to probe the thickness of the ice sheets in Antarctica and the Greenland, and to map shallow aquifers in the Sahara in the first 50 meters. And considering how much advanced ISRO radar program is, we are really looking even through this collaboration to involve ISRO, and that's one of the topics that was discussed actually the last month with our friends, the scientists in ISRO. So the second place I work is the Jet Propulsion Lab. It's very known for robotic missions, and it's managed by Caltech. So I am an affiliate of the radar division, which do basically radar and microwave instruments to observe planetary and Earth surfaces. The third place is the University of Southern California. So the University of Southern California is have a very strong engineering program in radar and microwave and aeronautics. And maybe for those young people who hear us, you might not know that Neil Armstrong, when he walked on the moon, so you know definitely this man, Neil Armstrong, when Neil Armstrong walked on the moon, he was a student of the University of Southern California. So a lesson learned for all of the young students who you hear us, that the first man who walked on the moon wasn't only an American person, but he was a student. And that is amazing. Neil Armstrong was a master's student. He enrolled in the master 6 months before the moon. He graduated 8 months after. So imagine you have a student walking. The first man is just an engineering student. So this is very good lesson for all of us. So as I mentioned, going to the moons, Mars, Europa, studying comets and asteroids has nothing to do with the propaganda of saying, we've been on the moon, we've been on Europa, we touched an asteroids, all of that. It's all about understanding our own planet. So Europa, for instance, an icy moon, a Jovian moon, Europa would be the Earth during the Ice Age. Under this thick ice, there is a global ocean that would represent our current blue Earth now. The moon play an important part of Earth's stability, and I will talk about it in detail. Mars, our sister planet, and is the older sister planet that turned into the desert, present the future of our own planet under its currently changing evolution. Asteroids like Vesta and Sirius and comets, these small bodies either are the mechanism by which you transport volatiles, which mean water and ice, across an organic material across the solar system. That impacts with bodies like us can bring volatiles and be responsible for making a body in the solar system habitable or not. So the moon, why we still go to the moon, why we are so important about understanding the moon. The moon is responsible for the stability of our Earth rotation. That is the stability of our climate. That is the sustainability of life condition on Earth. So understanding how the moon was formed tell us about the dynamic of the moon. So we believe today that the moon was formed by an impact of a small body, the like Mars-sized body, with the Earth hitting the upper crust of the Earth, and then the debris from this upper crust generated what is the moon today. So it consolidated. So the Earth would look like Saturn at one point, with all these rings that consolidated these debris to make the moon. So then why it is important to understand the inner part of the moon? Because understanding the subsurface of the moon tell us about all of the scenario, about the dynamic, and tell us this dynamic of this impact, tell us for how long the moon will have a rotation that can sustain habitability on the Earth. So that's what we've done using the mini RF and the mini SAR. So mini RF is a synthetic aperture radar on board the Lunar Reconnaissance Orbiter, and mini SAR was the radar on board Chandrayaan-1. And I was honored to be among the JPL team, the NASA team, who helped put Chandrayaan-1 in place. And for this, I'll tell you a funny story. So I was working on Chandrayaan from 2008 to 2012. And I was in charge of communicating with the scientists in ISRO who do the operation of Chandrayaan-1. And for 4 years, we communicated via phone. And I communicated with many scientists in the European Space Agency, in JAXA. But my partner in ISRO has something very specific. I told him, for 4 years, I called you, but I never heard your phone ringing. And very simple, because he will pick up the phone even before the first ring will finish. So for 4 years, we called at every single time of the day. And we have always this half an hour problem between India and the US in timing. And he would always pick before it rings. So I told him, is like the phone, you have it in the necklace or you have it always in your hand, it never rang. So, but that showed the dedication of people in ISRO. I mean, I was really impressed with the dedication, with the openness, with the transparency, and with many things that I haven't seen in many collaboration I worked with in space program. And really working with Minisar was a big pleasure. And the data I will show here, for instance, that came out of our paper. So we used the Minisar and Mini RF to look to, we used the radar return. I would not go in detail of it. We use that radar return inside of these impacts, the fills inside the craters. So we monitored about 30 crater. We look to the composition inside of the fills here, because these fills are excavated from the original impacts, where the depth of the fills are the material originating. They come from 1/10 about the size of the crater. So they will come from few kilometers deep. So we looked to these 30 crater we have on the moon using the Mini-SAR and Mini-RF, and we try to constrain the composition, looking for the iron content inside of these to try to see if the subsurface of the moon is more rich in iron than the surface, which would mean that the original body who hit the Earth hit a deeper part of the Earth and not just the upper crust, which will have implication to the moon dynamic. So basically, we have a relation about from this observation constraining the electrical part, so how conductive these fills to the size of the crater, and we concluded that the first few kilometers of the moon surface are depleted in iron, and deeper part of the moon are could be richer in iron, which means that the original impact happened with potentially a deeper part of the Earth. So that finding was put in the NASA press release last year on the 7th of July or the 2nd of July, and it was everywhere on the news, Fox News, CNN, you name it, and it was thanks to this collaboration between Mini-RF and Mini-SAR. The second the second body we look for with radar was Mars. I don't want to go in detail because Mars have all these fluvial activities that can relate to some of the fluvial activities, bodies we see on Earth. And we use 3 radar experiment actually to look to the subsurface of Mars. And we looked to the sapping feature that's very similar to what we see in Qatar, in the south of Qatar here. And basically, we were able to show that sapping feature are very similar to one we see in Qatar, and we published that in a paper in Nature, and which was actually also. So this one was about the sapping feature we see on Mars in relation to Qatar, and one about the ice we see on Vesta. I don't want to go to observation, and that paper was
Dr. Heggie, I think we lost a connection. We couldn't hear you. Can you hear us, sir? It seems we lost the connection with Dr. Heggie.
Let's wait for a minute. Maybe he'll reconnect back.
Yeah,
Also,
sure.
the quiz link is provided in the chat box for all the students. It has not been started yet, but the quiz link has been shared on the chat box.
I think he's back. Yeah.
Okay.
Okay, I apologize for the disconnection. I think let me okay, just to share the last part. Okay, I just want to say that I think without going through much in detail, so the knowledge we gain about looking for volatiles, which is ice on planet, is what we use today to train astronauts to go back to the moon and look for these ice on the surface of the moon, to use it as a sustainable resources for potential long-term human being. And we develop these radars that will be implemented on lunar vehicles that will help locate the ice when probing on the moon. And so this part of the training, and I will close here with this paper, which we did on the 20th of June, which is now accepted for review in the Nature Communication with our colleagues in ISRO about assessing water ice distribution near the poles of the moon. And thank you very much. And again, I'm very honored to be here. And I would just want to say that I'm honored. And Dr. Vikram Sarabhai has been an inspiring example, not only for Indian, but for all developed nations who seek space research. And also, one of the things I learned from his life, and I learned from all the Indian scientists I work with, that every single Indian I've seen in my life have this capability to beat all the odds, the present odds, to build a better future for himself, for his family, for the community, and for India. And the spirit for fighting for a bigger good, and the spirit of giving to the others is really the spirit I've seen in all the scientists I work with in ISRO, and the spirits of all the scientists I worked from India in general. And thank you for having me here.
Thank you very much, Dr. Hegi, for really enlightening us and taking us through your research work, your extensive work you have been doing, and sharing your thoughts. Thank you, sir. Thank you very much. Well, now I request Mr. Prakash Nayaji to take up question and answer session, and also we can open the quiz. Over to you, Prakash ji.
Thank you, Srinivas. And good evening, all. I'm sure that after this wonderful session, you may have questions and queries regarding this topic. Yeah, before we go into the question and answer session, let me remind you that the online quiz is about to start now. You can participate by clicking the link shared in the chat box. For those who are watching us through YouTube, you can type the link shown on the screen on your browser. Please make sure that you give your full name and email ID while registering on the online. Top 3 winners will receive the e-certificates. We'll try to declare the winners by end of this session. As you know that this online quiz is only for 10 minutes. We'll close automatically after that. So try to answer the question as quickly as possible. So coming back to the question and answer session, those who have questions to ask, please raise your hands and we will unmute you. And due to the time constraint, we request all to avoid a personal introduction, direct your questions to the person concerned. So there are some questions that's come in the chat box. This one is to Mr. Sudhi Kumar ji. Somebody was asking about, want to know more about Yogi Mitra, the ISRO human robot.
Vyoma Mitra.
Vyoma Mitra.
Okay. Okay, fine. The Vyoma Mitra is a robot which was conceived to put it in the first unmanned missions for studying some of the parameters. Basically, how the pressure, cabin pressure would be there, how the temperatures would be there, and how the effective the suits would be, what are the parameters that need to be observed, the positioning, the placement, such kind of things, probably except for assessing the heartbeat, such kind of biological parameters. Most of the parameters can be received if you just make a model of a human body. That is the reason we are aiming at the Vyoma Mitra. That is the purpose also. Probably taking that parameters, we can take the feedback and we can incorporate the necessary changes into the spacesuit and other associated systems.
Okay, thank you, Sudhiji. And one question, this is related to the space. Maybe Dr. Hegi can answer this. What is the sound frequency in space?
The sound frequency in space?
Yes.
There is no sound in space because there is no air. So if we're talking about the sounding radar frequencies, the sounding radar frequency we use, they are from 1 to 5 megahertz for Mars, and we have 20 megahertz, and then for Earth it's going to be from it's 45 megahertz central frequency and 10 megahertz bandwidth for the sounding radar we plan for the Oasis mission, which is the Earth sounding radar.
Thank you, Doctor. Suji, as one question is usually most of the projects you handle is on a challenge. So, which you think is your most challenged project you handled so far?
Okay. See, some of the normally the projects are unique in nature. No project would be similar because every project, it could be an infrastructure project, or could be a satellite project, or it could be a launch vehicle project. Some of the things will be routine. Some of the things means they go by designs, and once the setup is made, it is only just rolling out number of pieces. But infrastructure projects are very critical, are very critical. Let's say if you take the second vehicle assembly building, I need to tell something about the multiple technologies that are involved in the space, because they're for the interest of the children. If that building is 46 meters deep pile foundation in a sandy soil, 1 kilometer away from the sea, driving 43-meter deep piles using a mission rig and putting the piles, because sandy soil, even if you go just 1 foot, it will collapse. Just imagine what is the technology that is involved. Let us say 450-ton EOT crane, you have to lift it like a pencil. I have not shown those slides. Lift it and put it at 85-meter elevation. The 85-meter elevation, that is more than 250 feet. That means 25 floor, probably 250 means around 10 floor, or even 4 meters if you take. How many floors building it is there? Like a pencil, the 80-ton structure, which is 30-meter long, taking it and putting on the top of the building. Such kind of infrastructure is there. Infrastructure development is a Herculean task in this space. You just imagine another one. I'll just share you. When we are developing the track for moving the launch vehicle, the track will carry around 125 tons of axle load. That's what I mentioned. When we have called rights who are experts in the transportation, they amazed and they said that we don't have technology more than 12 tons and we want to learn from you. And in the world, when we have ordered for these rails and the track changeover system, Oslo is the party who supplied. They said first of its kind in the entire world, they are making these rails. First of its kinds. Because normally shipbuilding, they will carry a lot of weights. Even in the shipbuilding, such kind of structures were not available. So in the space, what I should say, okay, satellite parts like what Hegi said, the radars, the development of radars, the technology is involved, critical technology. It is a challenge because something we have to learn from the textbooks and experience it and make it to happen. When it is happened, we should really take proud. If it is not happened, we have to look back the lessons out of the failures and we correct ourselves. But infrastructure projects, technologically, they're also equally or even beyond the imagination of anybody, which involves very technological marvels. I should say each and everything in space field is a unique challenge on its own.
Thank you, Sudhirji. There's one question to Dr. Hegi. Is there any impact in space launch due to global warming?
I don't know. I think he has lost his connectivity probably. I don't think any global warming will have any impact on the space, because global warming is something a phenomena which is related to the atmosphere. It is nothing to do with the space.
Thank you, Sudhirji. There's one question, Sudhirji. It's asking that sound travels faster in space.
Sound travels faster in the space. Now, what is the question? Can you repeat?
No, it says, does the sounds travel faster in space?
I don't think sound travels equal thing. Maybe deterioration will be there because of noise and because of the dust. Probably, I think deterioration may be there. Noise will be added. I don't think any the change in the speed of the thing. I don't think.
Okay. So One more question regarding the ISRO. Says ISRO planning to collaborate with Elon Musk anytime soon?
The ISRO is a research body, research and government organization. If any fruitful collaboration is there, it is quite possible. For collaborating, somebody has to come forward. If it is, as long as it is mutually acceptable to anything, why Elon Musk? Even with God also we can collaborate if he comes forward.
Yeah. So there's one question. It says, what happened to the debris in space? If there is due to
Very nice question, very nice question. Because debris management is a headache of each and every national space agency. The debris, see, lower stages, let's say solid stages, which will burn maybe around 100 kilometers, they will fall into the sea. And maybe 100, 150 kilometers and 200 kilometers, they will slowly enter into the atmosphere. They will get burned themselves because of the travel, a lot of air friction will be there. But upper stages, which will be traveling up to 500 to 600 kilometers, they'll be there in the space for a long time. Slowly, because of air friction, they lose their altitude. Slowly, they will enter into the atmosphere. They will burn themselves. But very upper stages, 900 to 1,000 kilometers or even beyond, it takes huge amount of time to come into the atmosphere for getting burned. But till such time, they'll be moving around. And geostationary, especially in the LEO orbits, there is no such mechanism right now available to capture the debris and bring it back to the Earth. But several companies are working on these technologies. Hope that soon we will get an answer for this one. But in case of geostationary satellites, where the slot availability is very critical, what we plan is normally, we will, when some amount of fuel is left out, basically the life of the satellite is decided based on the amount of fuel that is stored in the satellite. Because in case satellite loses its altitude or attitude, using the thrusters and using the propellant on board in the satellite, we will correct it and bring it back to the correct position. When the fuel is exhausted in the satellite, so when a correction is required, when we cannot correct the altitude and attitude, then even though the hardware is active, we cannot make use of the payloads. So that means then we call it as satellite is dead. So for communication satellites, what we do normally, any space agency does is, when some amount of fuel is left out, we will just fire the thrusters so that the satellites will be pushed to the far beyond 36,000 kilometers, so that it will be there and it will be there forever moving around. And to reach the Earth, it may take thousands of years. That is how the debris is managed. But we are also, every space, national space agency, UN is, regulations are there. The debris management is the respective national space agency's responsibility. What I told, one multi-object tracking radar, it tracks the debris up to 50 mm by 50 centimeters by 50 centimeters. We will take a note of all the debris and manage the debris, and we are accountable also.
Thank you, Ruji. There's one question from Sir Ashkar Mohammed. I'm going to unmute you. You can unmute and.
Hi, sir. My name is Ashkar Mohammed. Sir, on what basis do we choose the materials used to cover the antenna? On what basis?
On what basis? On
Yes.
what basis means reflection, the sensitivity to the different frequencies, that the light weight, because if it is a satellite antenna, weight matters. That is why we go for composite structures, honeycomb structures. And if it is ground antenna, the reflections, the accuracies, the frequency sensitivity.
Okay, sir. Thanks.
Suji, there's one question. It's what type of fuel is most commonly used in rockets?
What kind of?
Fuel is most commonly used.
Fuel.
Yeah.
Fuel, see, it's a very simple question. If it is a solid propellant, it is all HTPB across the world. All national space agencies use HTPB based propellant. The aluminum powder is the fuel. Ammonium perchlorate is the oxidizer. HTPB is the binder. ammonia, that copper chromate is the burn catalyst. This is the solid propellant formulation with the different combinations, maybe 23% AP and 67%, 23% aluminum powder, 67% AP, 10% HTPB, 2% ACR, like that, activated copper chromate. If it is earth storable propellants, it is more predominantly N2O4 and N2O4 is the predominant, this one. If it is cryo, hydrogen and oxygen. There is a semi-cryo, what we call it as kerosene, is a aviation fuel kind of thing, which is very stable. These earth storable propellant, UDMH and N2O4 is the combination of earth storable. They are very toxic in nature. So normally many space agencies, they will avoid this earth storable propellant. And if you see other famous flights, the semi-cryo is predominant. Cryo is predominant because cryo will give you more thrust and long the carrying capacity. That's why cryo is very predominant for upper stages.
Thank you, Zaji. We have one.
Prakashji,
Yes.
Can we have some feedback from Dr. Lalitji, because he joined from India and it is too late. So,
yes, please.
Dr. Lalitji.
Sir, may I ask a question?
Yeah, we will continue with question and answer, but let us have some feedback from our dignitaries.
Okay.
Please hold on. Okay.
Thank you, Deepak ji. Basically, maybe on behalf of all the audience, what I can say is thanks to SIF Qatar for launching us into the space amongst all the constellation of the speakers around us. All the luminaries, particularly Sudhir ji, had provided us with the launch pad. Dr. Heggie had provided us with a vehicle to travel on. And that has really given a complete insight about what is happening in the space right from our planet Earth. And it's a right occasion to discover, deliver, and discuss on these issues that our audience, particularly who are youngsters, have a great scope with the technology. And if technology is adapted by them at this stage, I think then sky is also not the limit for them. So, and it's a wonderful presentations made by each one of you. It's a really, we will be all going home intellectually rich. And thank you once again to SIF and all our luminaries who were there to share their experiences right from the ground zero. So thank you again. Thank you very much.
Thank you, Dr. Lalitji. Prakashji, you can continue with the question and answer.
Thank you, Deepakji.
Yeah.
I think Mr. Nagendra Babu's question to us. I'm going to unmute you, Nagendra. Yeah, you can unmute and ask questions. Mr. Nagendra Babu.
Excellent. Thank you so much. And thanks so much for the very informative talks. And we all knew ISRO is a very impressive organization. I personally love the organization from the space science perspective, although I'm a biologist per se. My question is more on a side of climate change, and with the recent IPCC reports coming up and all the changes, climate changes are happening much faster than we have earlier predicted. I was wondering whether the stratospheric aerosol injection thing that I read about in the news, is that a viable strategy, or any of the space missions include any such strategies on the climate change domain?
Okay. See, aerosol is one activity being observed by all the nations. In fact, we have a very wide program. We are the national network. We have been observing how this aerosol is influencing the climatical changes. Yes, and many research papers were also published on the aerosol. How this aerosol is dispersed, how their climatical changes are happening. Is it seasonal or is it continuous? Some of the theories are there. Even I had interaction with a couple of atmospheric scientists. They say when you see the cycles, probably these only cyclical nature, and probably I think we need not have to much worry about the global warming or something like that. But some of the people says that, but these theories have to be established. Of course, there could be technology. There is no limit. For every action, there will be a counteraction as long as our brain works. Hope that some countermeasures will come with soon, and you are all the people who have to contribute for such kind of things. We also see we are only enablers. Okay, and ultimately we'll only get the data, make the measurements, and give the data to the research scholars. How the measurements would be. It's ultimately the field experts and the professionals who come out with the solutions. Hope that such kind of doping or such kind of counteractions should bring down the pollution levels.
Thank you.
Thank you, Suji. This one question is moon still get hit by meteors?
we really do not know because we are not observing. Because scientists will make facts only, not imagination. Maybe in cinemas you will find, because we don't observe them. Because if you put a camera and if you observe, probably answer will be there. We do not know exactly. I don't think, because God has given such a kind of beautiful gravitation, etc., etc. So such kind of things, I don't think, if at all such kind of things will be there, definitely scientists will have observed, because there is a mapping. Every day, even some of the tools will map, and the marginal changes the software people will observe, because such kind of research is going on. If moon is hit by some kind of objects and there is a marginal change, definitely scientists would have published some papers on this. I don't think such things will happen or has happened. Maybe could have happened in the past, but not so frequently.
Thank you, Suji.
Sir, may I ask one question?
Yeah, please.
Sir, what is the period of a satellite that launches in the space?
The period of the satellite rotation, or
Yes,
what?
satellite rotation.
Satellite rotation.
Yes, sir.
Okay, see, this depends on the orbit. Let's say if you have the observation satellites, which are polar satellites, every day, even 19 times, it can take one this thing. Let's say EO3, which is expected in the recent today. Unfortunately, that mission got disrupted. It used to take 4 times the observation every day. It all depends on the orbit that it is moving. Normally, 900 kilometers orbit satellites will take, I think, 2 to 3 rotations in a day.
Can I ask a question, Sudhirji?
Please.
We keep hearing reports of huge asteroids passing really close by to the Earth, and so do you foresee any damage to our space stations and to Earth as such?
See, this is what called the observations. What we do, space debris, is not only space debris, space objects also. Mm-hmm. We have a mechanism when such kind of, and it is a very frequent phenomena. Some debris or other will come in collision or likely collision with some space objects. In that case, there is a prediction, because NASA gives a lot of data on this, and we also have got some data. So whenever such kind of collisions will be there, that will be mapped, and prior actions will be taken, either transferring the path of the thing or otherwise what you call moving away or matching the period. But asteroids hitting International Space Station, okay, I don't think it has happened. Because normally these Kuiper belts, there are two belts in the solar system. In the meteoritic, around 1500 kilometers, there is one belt. And then again, 25,000 kilometers, there is another belt of asteroids. Normally, satellites, when we launch, between these two belts only we launch. That's why we never venture into going to 15,000 kilometers or 25,000 kilometers. Our LEO orbits always will be less than 1,000, MEO orbits around 25,000, and GEO orbits are 36,000. That's what the Kuiper belts, whatever you call it as, that we will avoid.
Okay. Thank you, Sudhir.
Thank you.
Master Vishnu has got a question. Vishnu, please, you can unmute yourself and ask the question.
Sir, I have a question. In space, a lot of satellites are launched from year to year and from a lot of years. So does any two satellites or three or more satellites collide each other in space?
That's what exactly just now answered. See, there were some instances that they claim that some satellite collision took place. It has become some international events also. We do not know whether it is inadvertently or deliberate. We do not know. But see, thing is, when you want to establish that two satellites got collided, there should be an observation. And it has happened in the past. Some papers were also published. And the NASA normally they do 24/7 surveillance of all space objects. Every space object is numbered and named, and they will monitor. But all of a sudden, after a couple of days, one space object was missing. So that means definitely it would have been collided by some other either satellite or some other object, space object, and that has become pieces. Okay. Normally, the satellites will not collide. Why? Because this is the very international consortium that ITU monitors all these activities. And when we set the parameters, because satellite will have several parameters, the position, the altitude, the speed, the location, all these things. So when we know the different position of different objects in the space, we put the satellites in such a way that it will 90-95% of the time it will avoid the collision, because in that particular orbit, as your satellite is moving, other satellites are also moving. As long as they are moving, they will move with same velocity. Otherwise, they will shift the orbit. If the velocity is locked, it is like fundamental things, centripetal and centrifugal forces. Centripetal force only keeps the satellite in a particular orbit. When it loses the velocity, it will drift down, and definitely the collision will be avoided in that particular orbit.
Okay, Suji. We have a question from Samruddhi Bharadwaj. Please, I'm going to unmute you. You can unmute and ask a question.
Prakash, 1 second. So it's, I think Dr. Sudhir is getting just 11 o'clock in India.
Yeah, okay. We'll end up with two questions. If,
okay, no
Sudhir
issue.
is okay with that.
No issue. Please,
Last
because I
two
enjoy
questions.
it. No issue. Because this is normally our time. We don't go to sleep between 12 o'clock.
Fine, perfect. So now you can proceed.
Thank you, Suji. Somebody, you can ask questions, please. You can unmute and ask questions.
Yeah, I wanted to ask, what are the ethical concerns behind colonizing other planets, especially with SpaceX looking forward to colonizing Mars? And if there are any ethical concerns, then do the monetary and social benefits outweigh the concerns?
See, this is the definition. This is a particular subject being discussed by all national space agencies, and UN charters are there. Nothing like nobody can claim a position in the space. Okay, that's why they have defined the international boundaries. What is space? What we call it as. The space doesn't belong to anybody. And if at all any colonization, anything to be done, that will be as per the international charters, which will be discussed in the UN Coopers, and a consensus has to be arrived. For technological, for demonstration, or for collaboration, for research studies, if something has to happen, either through a collaboration or through a particular national space agency, yes, that may be allowed. But that too has to be discussed in the international charters. Against the consensus only, such kind of things will happen. It is not private colonization. Just like that, our real estate, somebody will go and buy this area and start building the cottages and what you call hotels, and they encourage the space tourism. It will not be like that.
There's one question. It says, what are the components of solid rocket fuel?
Components of the, sir, I just told, no, you see the propellant is, the fuel is aluminum powder.
Yes. Yeah.
The oxidizer is ammonium perchlorate. The binder, which binds the solid propellant, is HTPB. The burn characteristic, this one is ACR, activated copper chromite. These are all the major ingredients. There are some small ingredients like F2O4, small traces of other small ingredients. They are very, very small, even 0.1%, 0.2% like that. These are all the major ingredients.
Okay. So I think now we can wind up the question and answer session. It's being too late in India also.
Prakashji, we can announce the quiz results now. Everything is ready.
Yeah.
Okay.
So you will be okay. Please, so you can announce the question.
So let me announce the winners for the today's quiz. There are 4 winners who scored highest and within the 50% of time. That is, it was for 10-minute duration, and they completed the quiz in 5 minutes. Okay. So let me announce these 4 winners today. Hiranmay Vijay Kumar, are you there? Hiranmay Vijay Kumar, congratulations. Next, Gauri Hari Prasad. Gauri, are you there? Congratulations. Next one, Vishnu Nalil Walapi. Congratulations, Vishnu. And 4th is Lavanya Baiju. Congratulations, Lavanya. Thank you all the participants, and congratulations to the winners. Thank you. You will receive the certificate of excellence within 3-4 days in your registered email ID. Thank you.
Thank you, Deepak ji. And thank you, Prakash ji, for the questionnaire. I know looking at the young minds and the curiosity, there are a lot of questions, but looking at the time constraint, we have to end the questionnaire over here. Now, may I request Srimati Shailaja ji to present vote of thanks. Over to you, Shailaja ji. Please unmute yourself. You're muted.
Yeah. Wow, that was really an amazing presentation. A very good evening to you all. It was indeed a privilege for SIF Qatar that we are celebrating Dr. Vikram Sarabhai's birth anniversary as a part of Azadi Ka Amritotsav. On behalf of SIFQ, I would like to thank Shri Sudhir Kumar ji and Dr. Isam Hegi, who gave us the elaborate insight on the space missions and programs happening in India, as well as Arab regions. Truly mind-blowing and lot of takeaways for all the science lovers. I would like to thank Sri Jayant Sahasrabudhe who accepted our invitation and addressed the gathering on this occasion. I would like to thank Srimati Angelina Premalata ji and Sri Babu Rajan ji who took the time out from their schedule to attend this event. I would like to thank all embassy officials, Qatar Foundation dignitaries, AO presidents, academicians, community leaders, principals, teachers, students, media personnel, sponsors, and all the science lovers who gave us their valuable time for making this session a success. Last but not the least, I would like to thank all SIFQ and SIF GCC team members who put in their efforts in conceptualizing, planning, coordinating, and organizing this event.